Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video, we will explore some more feature of CAN protocol and how these CAN features will help in communication. That part we will understand. Before starting the video, if you're new here to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded systems and automotive systems. Now, guys, you know that already CAN protocol is widely used in automotive system, and in the previous video, I have already explained what are the important features of CAN protocol. So when I say CAN, you will be knowing already. We'll be using two wires that is called as a CAN H and CAN L, and to these wires, we're going to connect our ECU in the cars. So we will understand one by one what are the different features of your CAN protocol. The first of all, the CAN protocol is asynchronous communication protocol. So try to understand the word here. So when we say CAN, basically it is asynchronous communication protocol. What do you mean by asynchronous? There will be no clock. We do not use any clock to transmit or to receive the data. But instead of that, we are going to use something called as baud rate. What is that baud rate? That I'll explain later. So first thing is, CAN is asynchronous communication protocol and is a half-duplex communication. That means simultaneously you are not able to send and receive, and transmission not possible. But one ECU has to send, other ECU has to receive, and vice versa. And this will happen in a million microsecond. That's why in real time it will not create a much problem. But CAN is a half-duplex communication protocol. And you know that already CAN protocol uses two wires that I have discussed. One is a CAN H and one is CAN L. We use two wires that's called as CAN H and CAN L, what you're seeing on the screen. The important thing starts from here. CAN, why we will be using CAN? Because of there are many reasons are there. One by one we will understand why we're going to use CAN in our automotive system. The first important thing with respect to CAN is, you know that already, CAN is capable of transmitting a data at very high speed, at the speed of 1 Mbps. In a regular embedded system applications like your I2C, UART, and other things, they are limited with the speed, but CAN is very robust and it is able to transmit a data at the rate of 1 Mbps and up to distance of 40 meters. This is one important thing you should know. The CAN is capable of transmitting a data at the speed of 1 Mbps and up to the distance of 40 meters. Up to 40 meters it is able to transmit, and how much data it can carry in a single transmission. The CAN protocol is capable of transmitting up to 8 bytes of data in a standard CAN. There are different variants are there that we have already discussed in the previous video. So I'm talking about a CAN standard or a standard CAN. It is able to transmit up to 8 bytes of data up to 40 meters distance at the speed of 1 Mbps. So we have extended version of CAN that is called as a CAN FD. This CAN FD is also called as CAN flexible data rate, and this, with the help of this CAN FD, we're able to transmit 8 Mbps speed. We're able to achieve the speed up to 8 Mbps, and we're able to transmit up to 64 bytes of data, and length of a communication, range of communication up to 20 meter, 10 to 20 meter distance we're able to transmit. So then we have extended CAN, one more extended CAN we have that's called as CAN XL. This is CAN FD and this is CAN XL. So CAN XL is capable of 2048 bytes and 20 Mbps speed. Distance limits only up to 10 meter. So these are all the different variants of the CAN. Because of these reasons, the CAN is capable of CAN is used in the automotive system. And you can see the last point as well here. We have low speed CAN as well. This low speed CAN, which is able to transmit at 125 kbps, and it can cover up to 500 meters of distance. So CAN will support high speed, low speed, medium speed, and very high speed. Because of this nature, we're going to use our CAN in our automotive system. So we will explore some more features. So now you can see here. So CAN is not a master and slave based communication. This we have already discussed in the previous video. CAN is a multiple master communication. Each ECU will be acting as a master. There is no control. No one will control our ECUs. There is no host machine. or there is no host computer to control your issues. Every issue is capable of understanding what message it has to transmit and what timing it has to transmit and how to recover from the error. All these things already we do the programming to the issue, then we will install in the cause. So no one required to initiate the communication, and no one is going to command in the in our automotive system. That's why CAN is not master slave based communication, but instead of that it's a multi-master communication. CAN protocol is having a fault confinement mechanism. That is nothing but if there is any error in the network, CAN itself, it is able to detect, and it is able to notify, and it is able to confine, and it is able to recover from the error. If there is any error in the network, so these 3 to 4 steps it will perform, and it will come out of the error scenario. So error detection is possible, error notification is also possible, and how to manage the error, that is also possible in the CAN protocol mechanism. So because of this also, this is also one of the strong reasons why we're using CAN in our automotive system. But how, that I'll explain later in upcoming video. How it is possible, that I'll explain later in upcoming videos. So next point here, CAN is address-based communication protocol. It's similar to I2C here. In I2C we use a slave address, but instead of that in CAN we are going to use a message ID. So what is that message ID? Every data frame will be allocated with one unique message ID. That's called as a ID, we will call our message ID. Using this message ID, we will be able to transmit a data, and we're able to receive that data. So CAN is address-based communication, and each message will be allocated. Next point, if you see here, each message or a data frame, so data what we're going to transmit, that will be allocated or assigned with a unique message ID. And this message ID will be of two types. You can go with a 11-bit message ID, or you can also go with 29-bit message ID. So in our CAN, they have given a flexibility. However we want, we can assign the message IDs. We can go with 11-bit message ID and 29-bit message ID. So when I go with 11-bit message, just you try to calculate this 2 power 11. So when I say 2 power 11, it's going to create a 2048. That means 2048 different messages we are able to transmit from one issue to other issue. And if you go with a 29-bit message ID, you will get in terms of crore of messages. In terms of crores, you will get. In terms of million, you will get the message IDs. So this is also one of the reasons why we are going to use a CAN in our automotive system. Because so in automotive system, each message will be having its own unique ID, and similar to that, we are able to generate up to 2048 different messages in the CAN for transmitting and receiving. Right? So this is one of the important thing. The next one is the CAN uses different messages to transmit and receive the data based on the different operation. You can see here CAN uses different frames for different operations. So if you want to send a data transmission, you can use data frame. If you want to send a data with a 29-bit message ID, then you can use extended frame. If you want to send a data in a 11-bit message ID, you can use data frame. You can use extended frame when you're going to transmit 29-bit. And whenever you want to receive a data, we'll be using a remote frame. Whenever you're going to notify an error, we will use error frame. And whenever there is an overload to the ECU, then our CAN ECU will use an overload frame. For different operations in CAN, we have different frame structures to transmit or to indicate the network that there is a error, or there is an overload, or there is I'm going to receive the data like that. So for different operations, we have different frames. So this is also one of the important reasons why we're going to use CAN in our automotive system. So one more thing about CAN is CAN uses our OSI model. So what is this in detail? I'll explain. I'll make one more video and I'll update later. Just you try to understand here only one thing. Our CAN protocol will use a layered architecture of OSI model. You might be knowing already. OSI model uses 7 different layers of communication. Like we have a physical layer, data link layer, then application, we have session layer, then we have presentation layer, then we have network layer, and finally we have application layer. Like this, we have 7 different layers are there. Out of that, our CAN protocol will cover two layers, that is a physical layer and data link layer. So what it will perform in these two layers, that I'll make one video later and I'll update in the channel. So next point is CAN protocol uses something called as NRZ. So what is this NRZ? That also I'll explain later. Just try to understand only one word here. CAN protocol uses something called as NRZ coding, and that stands for non-return to zero. CAN uses non-return to zero coding. With the help of this, we will not able to go to zero voltage, and we will, instead of that, we will stay between some 5 volts to 1.5 volts, something in between, or 5 volts to 1.5. How, that I'll explain later. Next, we're going to use a bit stuffing. CAN protocol also uses a bit stuffing. So what is this bit stuffing? In order to synchronize all your network ECUs, if you're using 10 different ECUs, all 10 different ECUs should be synchronized properly, and there should be a proper communication, and there should not be no loss of data. To ensure the synchronization between all the nodes or all the ECUs, so we're going to, and also to keep the reliability, we're going to use something called as bit stuffing. So with the help of this bit stuffing, we're going to insert an opposite polarity bit after 5 consecutive bits. So how to do that? That also I'll explain later in upcoming video. So just keep it in mind. We're going to use something called as bit stuffing in order to keep all ECUs or all nodes in a synchronized way. We're going to use a bit stuffing. And our CAN uses wired AND logic. So this also I'll explain later. This is nothing but a wire, CAN wire, since we're using a wire network here, that's why. And this CAN bus will act as a AND logic. That's why it's called as a wired AND logic. So CAN uses a wired AND logic, and it uses a differential voltage. What is this differential voltage? That also I'll explain. Just keep it in mind, CAN protocol uses a differential voltage technique to transmit the data by using 3 different voltages, 1.5, 2.5 and 3.5 volts. Using these 3 voltages, we're able to transmit and receive the data over a CAN bus. That term is called as differential voltage technique. And also CAN protocol uses something called as CSMA CD, that stands for carrier sense multiple and collision detection. So this also I'll explain later in upcoming videos. So CSMA CD, that stands for carrier sense multiple access, to determine the arbitration mechanism. And finally, CAN protocol uses a distributed arbitration process in order to prioritize your messages. So this is a very important thing, how the CAN protocol is capable of prioritizing the messages which is of high priority. So how, this is also one of the interview question. So bit stuffing is one important question you can expect, and this CAN layered architecture is important question, and what is the differential voltage? These 4 points are very important with respect to the interview. So all these things I'll be explaining in upcoming videos later. So keep on watching my YouTube channel. So now coming to the topic here, CAN protocol uses an arbitration mechanism. So arbitration is nothing but a bitwise operation. So it's nothing but a bitwise operation, and based on bitwise operation, your CAN protocol will decide which message has to go first and which has to go next. That process will be decided by distributed arbitration process in order to prioritize your messages. Okay, so these are all whatever I have discussed, almost around 20 points I have discussed. All 20 points are very important with respect to your CAN based interviews. If you're attending any automotive company, if you want to attend any companies related to automotive, please watch this video and go to the interview, and you will be able to clear those interviews. At least fundamental things I have covered in this video. In future, I'll make such videos. Each topic I'm going to explain in detail later in upcoming videos. So I hope this video is an informative video, and if you feel this as an informative video, please click on like button and subscribe my YouTube channel.